So here is video on lists, and then lists implemented as stacks and queues. So first of all, a list is a bunch of nodes. So here's one node. A node has data and a pointer. We'll link a bunch of nodes together. Bob, Sue, Joe. We'll link the bunch of nodes together with the pointers pointing to the next node in the list. The final node in the list will point nowhere, so null. Remember that nodes are objects. So if we wanted to add one on here, we make ourselves a new node. We'll put it up here. We'll call this node N1 is assigned new node. Well, this is an object. And what is an object actually? Well, actually it's an address. It's right here. What's right there? Well, let's just call it ABC123. I'm sure you can't see that in the video, but at this point, this bit in the address system of the memory of the computer is ABC123. So what we do is we set next, i.e. the pointer of the final node here, which we'll call it the tail. We'll call this one, by the way, the head. So we're going to set the next of the tail, the current tail, to be N1, which actually is ABC123. In other words, right to there. And we'll call this Phil. Now this, the newest node, points nowhere. The pointer is null. So this list is linked. If we start at the head with Bob, we can use a pointer to go to Sue, to go to Joe, now to go to Phil. They're all linked. So now to treat this list as a queue. Q-U-E-U-E. There are two things that we'll want to do to a queue. We'll want to add to it, which is NQ, and take the first item away, NQUEUE, and that is called D. Q. That adds, that takes away from the queue. And we take away from the queue in a first in, first out, or FIFO way. So that's what a queue is. A queue is where somebody goes would wait in line, or planes wait in line, or there's a line, and the first thing that was in is the first thing to leave. FIFO, first in, first out. Well, NQing, I've already done. Maybe we can do it one more time. We want to NQ, we want to add one more node, so we make ourselves a new node, N2, whatever it is, and we set the next, whoops, that's now the tail. We set the next of the tail to be the new node. We declare the tail now to be that last node, which points nowhere. So that is NQing. George is now at the tail. He's at the end of the queue. He's been added. To DQ, we're going to want to take the first in, first out. Well, the first in was Bob. Bob should be the first out. Bob should be the one that we deal with when we DQ. So how do we dequeue? Really quite easy. We deal with this. We get, I don't know, we do something like sout head dot get data, for example. So it's going to get the data of the head, which is Bob. And then what we want to do is make the next in the list to be the head. So after having done that, we're going to go head is assigned the current head dot get next. So the head is no longer this, the head is that. And so effectively, the list is now there. The queue now starts with Sue. Now, this is still in memory, there's still Bob, but we can't access it anymore via the list because it's not part of the list anymore, because we only access the list from the head. So there you go. We have dequeued Bob from the list, or from the queue. So enqueue, adding to the end, dequeue, just basically using the data and switching what the head was. Now we move on to stack. And I'm going to take this back to having Bob, just for diagram's sake. So we're back to the original list. Original list as it was with Bob, Sue, Joe, Phil. And actually we'll take this away too for the diagram's sake. Back to the original thing we got. This is the tail. This is the head. And now we're going to treat this as a stack. And remember with a stack that it's one on top of another, on top of another, on top of another, on top of another. The last thing in is the first thing out. So we can add to it, in which case we call it push. And we can take away from it, in which case we call it pop. Again, think of a stack of things. We push, 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 pop, 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 pop. Pushing is identical to enqueuing, because all we've got to do is add something else onto the list. So we'll make ourselves a new node, like we did before. And we will have the tail pointer point to it. And I'm running out of names, but John. Done. We just, and of course we switch now. The tail is the new node. So they're still linked. Link, link, link. Now, what was the tail is linked to a new node, and the new node is not linked anywhere. So pushing is identical to enqueuing. It's just adding on to the end of the list. But popping is going to be different, because when we pop, we want to pop the last thing that was added. Pop works on a last in, first out. For example, like with exceptions. The last exception dealt with is the first that needs to be, or the last exception called is the first that needs to be dealt with. So the last in, who was the last in? Well, it wasn't Bob or Sue or John or Phil, it was John. John was the last in. So we need to get the data from that, so we'll just do something like tail. So we'll sout, for example, tail dot get data. And we've done what we wanted to do. We've got our data, but now we no longer want this to be treated as the tail, to be part of it. We want to get rid of it, so all we need to do is break this link. So this gets a little bit trickier, how this happens. And basically the way that it works is we keep track as we're navigating through previous and current. Because the only way we can access, I'm not sure this has been said yet in the video, the only way we can access a list is via the head. So if we want to get rid of this and pop it, we got to work our way all the way to the end before we can pop it. So what we do is we're working our way through, is we keep track of previous, current, previous, current, previous, current, and as we're working our way through and we get previous current, and the pointer, the get next, is null, then we know we've reached the end of the list. But we've still got kept track of previous. So we're going to go previous node dot set next to be null. And that's it. Because if this is null, we no longer have access to this. This is orphaned. Oh, and then we need to set the tail. So tail, in terms of coding, becomes previous. The node called previous. So effectively we have cut off the last one that was added. And now the next time we navigate through this, previous next, previous next, previous next, next is null, this is the end of the line. This is as far as we get. So if we wanted to pop off something else, that would be it. Those are the basics. There are lots of notes, and I'll do this with an array, with a static array, in the next video.